Hey everyone, I'm out here in the garage. What we're going to be doing today is taking a look at the 2004 Honda Pilot's air conditioning system. So stay tuned. So if you're new to the channel, I just want to welcome you here and hopefully you'll consider subscribing if you like what you see. Also, check out Car Apprentice on Instagram, Twitter, and Facebook. I post lots of pictures and videos on those platforms before I post anything on YouTube. And occasionally I'll post things on those platforms I don't post on YouTube. Also, check out the website at carapprentice.com. And don't forget to hit the like button if you like this video. So as you can hear, it is raining pretty hard outside. We're actually in winter right now. So this video was filmed way back in the summer. But I figured I'd start plowing through all this Honda Pilot footage and try to get it out. So what we're going to be tackling today is the air conditioning system, which was not functioning when I bought this car. So, let's get into it. Alright, so I have the car partway in the garage, so I'll start it and turn on the AC to begin gathering some clues. As I put the key in the ignition and turned it to the accessories position, the first and most obvious clue I chose to ignore, for some odd reason, is a buzzing noise coming from the dash. I had heard something similar in a Pontiac Vibe I repaired about 5 years ago, but it completely slipped my mind. Some of you may already know what this noise means, but we're going to take the long way to get to an eventual primary root cause and take care of a couple of much needed maintenance items along the way. The blower motor is working just fine, but the stem thermometer is indicating that the vent air temp is rather high at somewhere around 95 degrees. Before we dive in, this is a screenshot from an AC avalanche video that provides a simple explanation of how most modern automotive AC systems work. I'll put a link in the description below to their full video for you to check out. Also, I've mentioned some popular AC system videos on the Ratchets and Wrenches channel in the past that may be of interest. As you can see, there are several components involved in the proper functioning of the AC system, with the compressor being at the heart of it. If the compressor fails catastrophically, metal shards can be sent through the system, causing the compressor, condenser, receiver dryer, and expansion valve to all possibly need replacing so the system functions normally. I've had to replace several components on the Acura Legend in the past to get the AC functioning, so this was my main concern that nearly led me to pass on this car. I'm going to use the FJC6697 manifold gauge set to check the system pressures. This kit works for R134A and R12 systems. The set includes the low and high pressure gauges, a red high pressure hose, a blue low pressure hose, a yellow charge hose, and some fittings. Also, I'm wearing gloves and goggles for protection. With the car turned off, I made sure the low and high pressure valves on the manifold were closed by turning them clockwise. I then screwed the blue low pressure hose's non-Schrader end onto the manifold gauge and did the same with the red hose. Next, I screwed the blue and red R134A adapters onto their respective hoses. Then I removed the blue cap from the AC system's low pressure port and attached a low pressure line, and repeated this step for the high pressure line. The car is turned off, so the pressures on the low side and the high side are about the same, which is normal. I started the car and turned on the AC, then read the pressures. The current pressures are around 18 psi on the low side and about 110 on the high side. Based on an outside temperature in the upper 70s, a chart I found online that seems to be consistent with other charts I've seen shows that the low side pressure should read somewhere between 35 and 50 psi, and the high side pressure should read somewhere between 150 and 210 psi. So we may have a very slow leak, but I'm going to charge the system and see how it does. I'm jumping ahead and I've already charged the system a little bit, but we'll add more refrigerant to bring the pressures up to optimal levels. I'm filling the system with 12-ounce self-sealing cans of refrigerant that require a can tap instead of the DIY cans of refrigerant sold at auto parts stores that only include a low side gauge. There's a danger that the system can be overfilled if the high side pressure is not monitored. See the link in the description for a more detailed explanation of can styles. Also, none of the refrigerant I'm adding contains any sort of stop leak additive, as some shops who evacuate AC systems before system repairs are performed will refuse to recover refrigerant that contains sealant. The non-Schrader end of the yellow charge line gets connected to the center inlet of the manifold, and the other end is connected to the can tap. I unscrewed the can tap's knob counterclockwise, then screwed the can onto the tap. I started the car, then turned the AC on to max cool and high fan. I could hear the compressor's clutch engage, so we should be able to continue feeding the system with refrigerant. Next, I screw the can tap in clockwise to release the refrigerant from the can and into the yellow line. To remove air from the line, I pressed on the Schrader valve at the manifold with the screwdriver until a hint of refrigerant flowed out. I then opened the low side manifold valve by turning the knob counterclockwise to fill the system. As the system filled, I closed the low side manifold valve periodically so I could accurately read the pressures. I noticed that the low side maxed out at around 35 psi and the high side pressure started to build up. So I closed the low side manifold valve at a little over 200 psi on the high side. Now that the system was recharged, I turned the can tap's knob counterclockwise to raise a plunger in the can and seal it. The Schrader valve at the center of the manifold can be pressed with a screwdriver to relieve any remaining pressure from the yellow line, then the hose can be removed. The last thing was to disconnect the couplers from the low and high side ports, then reinstall the ports caps. Well, the temperature at the vents in the cabin did not change, so we'll move on to checking other parts of the system.